Alright, we are going to find the domain of a function and work through this finding the domain of the function worksheet here. So, I'm just going to read through it to start with and we'll do some examples. So, the domain of a function is the set of all possible values that can be used as inputs for that function. The domain is the set of all allowable x values, or your input values here. And the range is the set of all possible output y values. Okay, so in general, we start by assuming that the domain is a set of all real numbers, and then there are three main exceptions. Okay, so we start with the set of all real numbers, which essentially means that we think the domain could be anything. And then we have some exceptions we got to look out for that'll cut that domain down. Exception 1. The function contains a fraction having the input variable in the denominator. In this case, the domain is all real numbers for which the denominator is not equal to 0. So, for our procedure here, we set the denominator not equal to 0, and we solve for x. So for this example here, we've got this function h of x equals 77 over 4x plus 9. We set the denominator here equal or not equal to 0, and we solve. And so simply here we are subtracting 9 on each side, and then we're dividing by 4. So our domain here, we see that x cannot equal negative 9 over 4. So the way that we can write this in interval notation is we'll start with negative infinity, we'll go up to negative 9 over 4 and not include it. And we'll union that with negative 9 over 4 not included all the way to positive infinity. Essentially getting rid of that single 1 point there at negative 9 over 4. Because remember, when you're doing interval notations, parentheses means it's not included, brackets means it's included. Now with exception 2, it says the function contains an even indexed root whose radicand contains the input variable. The radicand must be positive in this case, and so the domain is the set of all real numbers for which the radicand is greater than or equal to 0. So what you're going to do is you're going to set that radicand greater than or equal to 0, and then you're going to solve for x. So here, with this example, we've got g of x equals 56x minus 7 square root 6x minus 11. Now, we're not worried about this 56x and this minus 7 multiplied part. We're worried about what's under the radicand. And if you remember, the radicand is just your radical sign here, the square root. We're worried about what's under it. So we're going to take what's under it, and like it says here, we're going to set it greater than or equal to 0. So we've got 6x minus 11 is greater than or equal to 0. We're simply going to solve. We add 11 to both sides, and then we divide by 6. You still have to follow your inequality rules, so if you divide by negative here anywhere, remember you have to switch the sign, but we didn't have to here. So here we wind up with x is greater than or equal to 11 over 6. And if I wanted to write that in interval notation, the way I'd write that domain in interval notation is bracket, because it has an equal to sign with it, bracket 11 over 6, comma, infinity. So first one, we need to look out for what's in the denominator, right? And the second one, we need to look at what's in the radicand. Okay. Now, exception 3 says the domain is limited by the problem situation. So sometimes you have a lot of word problems, and you need to read through those word problems to make sure the problem itself isn't limiting the actual domain. So in this example, it says the amount of money lost by playing Alfred's self-adapting slot machine is a function of the number of quarters gambled. And Alfred claims that the loss can be approximated or approximately modeled by the function f of x equals 300 minus the square root of 90,000 minus 3x dollars, where x represents the number of quarters gambled. It wants you to find the domain of the function f. So what we can see here, okay, by our radicand rule we just did with exception 2, is we need to take what's under this radicand and make it greater than or equal to 0. And when we do that and we solve for x, we notice here in this step that we have to switch because we're dividing by this negative 3. We have to switch this inequality. But we find that x needs to be less than or equal to 30,000. Okay. This suggests that the domain is going to be negative infinity to 30,000. However, because it's a word problem here, the word problem suggests that maybe the domain isn't necessarily this entire domain that we think it is. So since we can't gamble a negative number of quarters or a fraction of a quarter, this domain can't be, one, it can't be negative numbers, but two, it also can't be fractions or decimals. All it can really be is whole numbers starting from 0 and going up to 3,000. So instead of saying your domain is negative infinity to 30,000, what the correct way to say it would be that your domain is x, such that x is a whole number that is less than or equal to 30,000. And if we noticed here, looks like I have a slight typo because I need to do 30,000. So apologize for that. So essentially what you're looking at, you could write your domain this way, all the way up to 30,000, or you could write it this way. But what you don't want to write is that it's negative infinity to 30,000, because obviously you can't gamble a negative amount of quarters. Wish it did work that way. Now if we can move on, we can find the steps to finding the domain. So it's pretty simple. One, you start out with this all real numbers. Then you start to omit or throw out anything that doesn't make sense according to the problem. So step number 2 says omit or throw out anything that causes a division by 0. So in order to do that, we're going to set the denominator equal to 0 or not equal to 0 and solve for x. Okay. The next thing we're going to try is we're going to omit or throw out anything that causes basically a root of a negative for any positive even integer a. So you don't have to worry about the odds here, because if you think about it, the cubed root of -1 is just -1. Actually, any odd root can handle negatives. The only roots that cannot handle negatives are even roots. So if you have an even rooted thing, you have to make sure the interior of that root is not negative. So for now, non-real outputs are not allowed. We're going to set the radicand greater than or equal to 0, and we're going to solve for x. Now you can have situations where you have to do both step 2 and both step 3, and actually step 4 as well. So don't think it's just going to be one step or another. You might have to do all 4 steps. Remember, step 4 says if the domain is limited by the problem situation, adjust the domain accordingly. And sometimes that takes a really good thought process working through the problems. Now we do have some additional examples on this worksheet. As you can tell, there's 4 pages of it. I might not do all of them, but you should be able to work through all of them. You've got these exercises here on page 3, I believe it is, and the solutions are at the end of page 4. So you can go through and try all of these on your own for extra practice. I'm going to do a handful of them, and the rest will be up to you. If you have any questions on them, obviously send me an email and let me know what you're struggling with and why you can't get that answer. So let's look at this part A. So if we're looking at this one, we've got f of x equals 8x to the 7th plus 333x to the 4th minus x minus 5 pi squared. Okay, so if we look at it, there's no division here. There's also no radical. So, and it's not a word problem either, so we don't have to worry about that limitation as well. So simply put, our domain is going to be negative infinity to infinity. Pretty simple. If we look at B, we've got a radical, but it's an odd radical. So we have a 9 here. So it's not even. Therefore, since the index of the radical is odd, I don't have a division, and it's not a word problem that's going to give me some weird situation where I have to throw out numbers. The domain is simply all real numbers, which is negative infinity to infinity. If we look at part C here, we actually wind up with an even radical. So we've got an 8 here. Means I have to look at the inside here at this 3x minus 5. Now when I do that, I got to set that 3x minus 5 greater than or equal to 0. And then I have to solve for x. Pretty simple process. I notice that x needs to be greater than or equal to 5 over 3. Therefore my domain is 5 over 3 all the way to infinity. Now it's equal to here. It's greater than or equal to. That's why I have my bracket here. If it was just strictly greater than, remember you would only have a parentheses. That's really, really, really important. I'd hate to see you get points taken off for putting a parentheses rather than a bracket. Alright, D. D says f of x equals 4 plus 5x minus 2 over the square root of 7 minus 3x. Now we have 2 things to worry about here. One, we've got a radical, that's even, because if it doesn't give you a number here, it's assumed to be a 2. And we also have it in the denominator. So it exhibits two domain restrictions here. Exception 1 gives the restriction that 7 minus 3x cannot be equal to 0. And exception 2 gives the restriction that 7 minus 3x has to be greater than or equal to 0. Well, exception 1 has already canceled out that equal to part here. So exception 1's already caused it to say, okay, we know it's definitely not equal. So that means that 7 minus 3x needs to be strictly greater than 0. So we have to combine our exceptions and take it as limited as possible. So that when we do that and we solve, what we wind up with is a domain that is from negative infinity to 7 over 3. So like I said, you've got all of these exercises on this page. Give them a shot. See, if you want to really know what you're doing, go through and try each and every one of them. If you struggle with one, let me know. If we need to come to my online office hours and ask me about a few, please do. I'm not going to go sit here and go through it. The part of this course is that you work through it after given some information. So work through these and see that you can go through them. If you can't, obviously let me know. I can go through them on my online office hours, no problem. So hopefully this domain worksheet here helps you out. You understand the exceptions. You kind of see the exercises. Note that you can use more than one of the exceptions. Sometimes you have to use all 4. So go through, give it a shot. If you need any help, just let me know. Other than that, go ahead and finish this up, and then jump on the dimensional analysis worksheet that you'll also have to look at today.